Welcome back to another Brush Up on EMS with Bob. Today we're going to be talking about end tidal CO2 and how it relates to the body. So here before you, you have a screen that's showing the diagram that I created dealing with end tidal CO2. So what I'd like to draw your attention to is the very middle, right here. Okay, and what that is the very center of everything dealing with end tidal CO2. When we talk about blood, we know that blood, its pH is 7.35 to 7.45. But what is pH? Well, pH is that thing that deals with acid and bases. And so over here on the left-handed side, we have acidotic. And over here on the right-handed side, we have alkalotic. So what I would like to state is that acids are anything from 0 to 7. Okay? And then the bases are anything from 7 to 14. Now I would like you to imagine that we also put on this scale the respiratory rate, and that it just so happened that all of these were actually mathematically figured up, and that's why all these lines are here where they are. But this is just a simple diagram to help you understand better. So what's our normal respiratory rate? Well, our normal respiratory rate is 12 to 20. So with that in mind, we put another dot here in the middle. So we had our 7.35 to 7.45, and we had our 12 to 20 there in the middle. So that's when we put that dot straight there in the middle. And that's also where we had our dividing line going down the middle. Now the interesting fact about this is the fact that our blood's pH is 35 to 45, and actually what we see here is that our pH in our blood actually deals with exactly the end tidal CO2 of 35 to 45. And so when we're talking about alkalotic, we can say that someone is alkalotic in respiratory alkalosis from 0 to 35. And someone who is in respiratory acidosis is going to be 45 to greater than 45 millimeters of mercury. And all of this, the blood's pH, the end tidal CO2, and the respiratory rate all play a role. Now we know respiratory rate, anything less than 12 is slow, and anything greater than 20 is fast. So how does this deal with our patients when we have someone who has a narcotic overdose, or someone who, maybe is having a hyperventilation? They're breathing super fast. So what are we talking about here? So we have a narcotic overdose, specifically was put an opiate, and it's causing them to breathe really slow. So how do we correct that? Well, we know that if we have an opiate overdose and we put end tidal, we should be expecting a number greater than 45, something like, let's say 55. Okay? And we see 55 and we're like, whoa, this is not good. And we see a respiratory rate that's really slow, and they're breathing 4 times a minute. And we're like, how do we correct this? Well, what you need to do is you just have to look to the other side, and you say, how do we correct this? Well, you draw your attention over to this side, and all you have to do is speed up their respirations. Okay, what about the opposite? We have, hyperventilation over here, and we know that their end tidal is going to be down here somewhere, let's just say around 20, and we're like, this is not good. We need to fix this. So we have hyperventilation. We need to slow them down. So you look at the other side of the equation. So what I like to say is this is an equal sign right here in the middle, and hyperventilation, we kick it back over here, and we slow their breathing down. How do we slow it down? By bagging them, or we also could do some coaching. These two types of things, we can slow their hyperventilation down. We can get them back to normal, and then we're going to be getting them back to that 7.35 to 7.45, that normal blood pH, and they're no longer going to be in the acidotic or alkalotic states. So this is just a simple breakdown with when we're looking at end tidal CO2 and we see those numbers with our boxes, or we see our shark fins, and we see a number associated with that, 35 or 47. We see our numbers, we know that 35, they're going to be normal. And if we see 47 and we see a bronchospasm, okay, well, we know that they're over here. It means they're breathing slow and they're not getting enough air in, so we need to do an albuterol treatment to correct that bronchospasm there. And also we might need to speed up their ventilations. Maybe they're getting really tired. So maybe one thing we might consider with someone like this who has a high end tidal and they're breathing really slow, okay, is the high end tidal because they're retaining that CO2 and we need to get that out of there? Or is that high end tidal because they're breathing slow? So we correct it with albuterol, it might come down, and maybe we need to be considering some CPAP with this person. So that's just some things to consider when we're talking about end tidal CO2 with patients at the EMT level and higher up to the advanced level providers. But end tidal CO2 is pretty interesting, and I really enjoy it. So this has been another short minute from Brush Up on EMS with Bob, talking about end tidal CO2. You guys have a great weekend.